Here are some tips on how to use this guide. The guide itself contains 3 types of content. LabVIEW code examples. These are downloadable projects that you can run and incorporate into your own projects. Procedures. These are routine procedures that accomplish certain tasks. And the third is thematic guides. These pages give you an overview of a related concept and then link to code examples and procedures. Let's take a look at one of the code example pages, this one dealing with interrupts. Each one of these pages includes the use cases, features, and caveats for the code, the significant LabVIEW block diagram elements and functions that are demonstrated by that code, and then a zip file that gives you a complete working project that you can download and run. The video shows you the expected results of running the code, and then the walkthrough shows you the structure of the code and explains how it's all put together. The content is tagged in a number of different ways, and you can find related content this way. For example, you can find other code examples that use the interrupt express VI. You can also get to that page by clicking on one of the icons in the middle of the page. That brings you to the same place. Here's more examples involving the flat sequence structure. Let's move on to procedures. As an example, managing the Academic RIO device software set add-ons. There's a video that walks you through the step-by-step procedure, and this is also printed on the page as well. Here's another one that tells you how to set the system time and date of your real-time system from a browser. The third type of content is the thematic guides. These introduce and give you an overview of a particular theme, and then you have links to the relevant code examples and then procedures. You can even find additional guides on these pages. Technical terms from the glossary include this hover mechanism in which you see the short definition. Click on it to go directly to the glossary, and you can also get to the glossary from the sidebar. Back on the home page, the content is grouped according to 4 tabs. We have the Quick Start Guide. This is the recommended sequence to get started with RIO programming. The next tab is for the real-time target. And looking at the LabVIEW RIO architecture, we see that we have the processor, the FPGA, and the I/O, and so forth. So everything on this page is devoted to the real-time processor. FPGA programming focuses on the FPGA target. Finally, networking is all handled by the real-time target, or the real-time processor, and you have these topics available. The navigation bar on the left duplicates these 4 index tabs on the home page. The website is put together using fluid website design techniques, and this means that it scales nicely for your various mobile platforms. The sitemap lists out the content in a variety of ways. For example, you can look up content by tags. You can look up content by LabVIEW block diagram elements and functions. The various target types, for example, real-time target, PC host, and FPGA. Style of communications between the targets. And then finally, the sitemap for all pages is handy, especially for your browser's in-page search function, using Control F to search for specific text. Alright, last thing. This is what I suggest you do for your next steps. Take a look at the introduction and software setup, learn about RIO and Academic RIO device, browse some application examples, and then follow this step-by-step tutorial to make your very first real-time application. I'll give you a quick preview of this video. It takes about 25 minutes to work through the whole thing, but here you get a sense of it. Here's what we're going to make. We'll create a VI to run on the real-time target to blink the onboard LEDs. This will also serve as the startup VI for the Academic RIO device. We'll also create a human-machine interface running on the desktop computer to interactively control the VI on the real-time target. We will use the default FPGA personality and associated academic RIO toolkit express VIs that run on the real-time target.